Hi, this is Dr. Mary Hansen, and this presentation is on interpreting SPSS output for a dependent samples t-test. SPSS provides three tables of output when you run a paired or dependent samples test. The first is a table of descriptive statistics. The second is a table that has the correlation between the two sets of scores, and the third is a table that has the results from the t-test. Whenever you run any test in SPSS, you should have the null and alternative hypothesis specified. This output is from the dependent samples example that was utilized when showing how to generate SPSS output. The null and alternative hypothesis for this test are that the null is the mean for the during heartbeat group equals the mean for the between heartbeat group, and the alternative is that mu during is not equal to mu between. Recall that the dependent samples case requires that both the during and the between measures are on the same subjects. When we look at the descriptive statistics, we do see a difference in the means. During heartbeat, the mean is a little bit lower, 92.7 as opposed to 95.5. The statistical test will determine if that difference in the sample means is enough for us to conclude that the two populations are different. These descriptive statistics are also provided, the sample size, the standard deviation, and the standard error. The second table provides the correlation coefficient between the during and between heartbeat measures, and also the p-value to test whether that correlation is significant or not. The third table is the most important table because it provides the results from the statistical test. Note that the difference is defined as during heartbeat minus between heartbeat. The during heartbeat group was smaller than the between heartbeat group, so we would expect that mean difference, during minus between, to be negative. And you can see that the mean difference is negative. The output here shows the direction of the differences that the means are taken. The difference in means is provided, and the standard deviation of the different scores is also provided. A confidence interval on the mean difference is provided, and then the last three columns provide the t-test statistic, the associated degrees of freedom, which are n-1, the number of pairs minus 1, and the p-value of the test. When we look at the results for the dependent samples test, we get that the t-test statistic with 5 degrees of freedom is negative 2.629, yielding a p-value of 0.047, which is less than 0.05, so we reject the null hypothesis. Therefore, we do have evidence that the difference between the number of shots fired for the marksman when they fire between as opposed to during is significant at the 0.05 level of significance. Again, the mean difference indicating that during heartbeat, the mean is lower than the between heartbeat mean. Because we are comparing the p-value at the 0.05 level of significance, we do see that the results are significant. One thing to note is that if this test were run at the 0.01 level of significance, we would compare 0.047 to 0.01. The p-value in that case is greater than the alpha of 0.01, so we would not reject at the 0.01 level of significance. Again, this presentation is by Dr. Mary Hansen on interpreting output from a dependent samples test.